Okay,
This
let's
conference will now be recorded.
1 second. Okay. So is it fine? Is it visible to all of you? Because the other windows are hiding my PPT. That is the reason why I'm minimizing it. Is it okay? Is it visible? My screen is visible. The text size is bigger enough
Yes,
for you
ma'am.
to see. Okay, thank you. Right. So matplotlib is the most popular data visualization library in Python, and it's mainly used for plotting 2D plots. Okay, it is the most widely used library for plotting in the Python community and is more than a decade old. So it contains generally matplotlib is used in it has the plugin to use it in Python or IPython shells and also in Jupyter Notebook and also in web application servers. So you can very well use matplotlib if you have downloaded your Jupyter Notebook from Anaconda distribution. So if you have downloaded your Jupyter Notebook, if you are using Jupyter Notebook as your Python IDE, Integrated Development Environment, from Anaconda distribution, then matplotlib comes along with it. You don't need to explicitly download it using the pip command. It comes automatically with the Anaconda distribution. Okay, and
Excuse me, ma'am, you can.
Yeah,
Ma'am, you can minimize your screen. You can maximize. I'm sorry, maximize the screen. It is not visible properly.
That is what I asked. If I maximize, these windows are actually hiding. Okay, I'm trying to.
Okay, ma'am, then leave it.
Okay, let me just zoom it so that you. Is this fine? Once again, the Jupyter Notebook you will be able to see. Only the problem is with the PPT. Okay, so Plotly is used generally for.
Jupyter is not visible.
No, I'm not displaying Jupyter Notebook as of now. Only the PPT I'm displaying as of now.
Okay, ma'am, fine, ma'am.
Right. Okay, so here, as I already said, Plotly has got some advanced features mainly used by the industry professionals. Okay, so it has got some interactive visualizations, which is very much useful for displaying any kind of data visualization that will be submitted to the top management. Okay, so say for example, the specific plots like contour plots are specifically available in Plotly. There is a free version available. The Plotly free version is also available. So those who want to explore can go ahead and explore the features that are available in the free version. And another important library is Seaborn library, which has got some more advanced features. So Seaborn library is built on top of matplotlib, but it has got some more advanced features than matplotlib. Okay, so even the coding is also very much easier in Seaborn than matplotlib. So those who are already familiar with MATLAB, they will find the plots in matplotlib are much similar. The code to write, the code to create any plots, any graphs in MATLAB, the same syntax you will see in matplotlib too. You will find it easier. So Seaborn is much more advanced. It has got much more advanced features than matplotlib. It is built on top of matplotlib. Okay, so let's see. So just I explained what is the difference between matplotlib and Plotly. So I don't want to spend much time in theory because I just want to show you, demonstrate on various graphs. So I'm just skipping it. I'll share the PPT. You can just read it. So these are all the things that we are going to see. The different types of charts in Python are, so I have categorized them into the charts that are useful in doing univariate analysis and the charts that are useful in making bivariate analysis. In case of bivariate analysis, the meaning of univariate analysis is you are going to visualize the data in a single column, okay, or a single attribute. Okay, so for that a number of charts are useful. Say for example, histograms, distribution plot, box plot, count plot, line plot, or area plot, pie plot. These plots you can use for visualizing the data that is available in a single column in a data set. Okay, so I hope you understand the meaning of a data set. We can imagine the data set as a structured data in which the data is organized into rows and columns. Okay, right. So the Python's pandas library helps you to load any data set in the structured format, okay, as a data frame. So once you have loaded your data set into a pandas data frame, you will be able to visualize them by applying any of these charts, and then you can visualize it easily, because the human brain can understand the visuals very easily than the theoretical part, right? And the bivariate analysis is about how if you want to compare, if you want to visualize the relationship between two variables. Okay, so in this bivariate analysis, again, I am going to categorize them into numerical versus numerical. So both the variables that you are going to compare, if both of them are of numerical type, because the variables are categorized into numerical and categorical, there are two major categories. Okay, so if you want to perform an analysis on two variables in which both the variables are taking numerical values, in that case you can go for these charts: joint plot, column plot or bar plot, scatter plot, pair plot, and the linear regression model plot. Okay, in case of if you want to compare a categorical variable with a numerical variable, then again there are a set of plots available for that: strip plot, swarm plot, box plot, bar plot, and point plot. Okay, so I'm going to demonstrate each of them, how you can actually visualize the relationship between any two kind of variables. If both the variables are numerical, which kind of plots you will make use of. If one is categorical, one is numerical, how will you visualize it? Okay, so and then the multivariate analysis, we are going to discuss about the multi-channel categorical plot or factor plot. Okay, so now let's just move on to the Jupyter notebook. Do you see my Jupyter notebook?
Yes, ma'am.
Okay, so this Jupyter notebook is an IDE. It is an integrated development environment for writing any Python code. So you can download it from Anaconda distribution. So once you have downloaded it, you can easily download the free version available from the Anaconda website. So once you have downloaded, you will find some of the tools here. For example, once you install Anaconda, you will find these softwares are being installed in your machine if you're using a Windows operating system. If you're using a Mac OS, then only Anaconda Navigator would be there, inside which you will have a link to Jupyter Notebook. So once you click on this, it will open up a command prompt like this. It will open up a command prompt like this. So this is the in this command prompt, actually any Python code can be executed by a kernel. Okay, so it is like a command line interface where any Python command that you give in the Jupyter notebook will be executed at the background by the kernel. So you should not close this command prompt. So you have to open it up, and automatically it will open up the Jupyter notebook in the web browser. Whatever is the default browser, it will open up the Jupyter notebook. So initially you will see the home page like this, in which all the files and folders will be visible. Supposing if you want to, actually this is hiding. Supposing if you want to create a new folder, you can do that. Okay, you can create a new folder. Supposing if you want to create a new Python notebook, you can, since I have installed the Python version 3.7, it is showing me Python 3. Supposing if some of you are already started using Python version 2, then you can download the Jupyter notebook for Python version 2, because the Python community maintains both version 2 and version 3 simultaneously. Okay, so the current version is 2.7 as well as 3.7. So the beginners can go with the version 3. and then you can create like this. So now I have already created a notebook, and then once you click on the specific name, specific file, it'll open up the file for you. So you will see this is the interface of Jupyter Notebook. If you see here, there are a number of menus: file, edit, view, insert, cell. So as I told you, once you open up a new notebook, it will show you a cell, a command cell, a code cell otherwise. Okay. So you can type any Python command in it. You can type any Python command in it, and then to execute your code, to execute your code, let me show you here. This is a cell. I just insert a new cell. So supposing if it's A2 plus 2, this is as simple as so Python language is very easy to learn. The syntax is very easy to understand, right? So this is a code cell. So whatever command I want to give, I can give it, and then to execute the cell, I can click on this button, or I can click on this this icon, or I can use the shortcut key Shift plus Enter together. Shift plus Enter together. Okay. So now here I just want to give a title to my. I want to give a title to my Jupyter Notebook. So here I have given the title as data visualization in Python. So if you see here, you can give a heading. You can choose a heading. So the type of cells would be heading. It could be a heading cell, or it could be a markdown cell, or it could be a code cell. Okay. So here, if you use double hash, this is the level 2 heading. This is something similar to the HTML header tag. Those who are familiar with HTML must be able to understand what I'm talking about. So it depends upon the size. Okay. So supposing if I'm using double hash here, the size will reduce. If I use multiple hash here, accordingly the size will reduce. So this is going to be my topmost heading. So therefore I just want to have it in the bigger size. So I use a single hash followed by a space. If you omit a space, it won't work. Okay, you have to have a space in between, and then press Shift Enter. Okay, so this is the title I want to give. Now I don't want to have the cell. I want to delete it. So I'm going to use the shortcut means the default icon which is available here. Okay, so and then if the important ones I'll explain. If you want to download your Python notebook as, a HTML file, you can download it as a HTML file, or you can download it as a IPython notebook. Okay, so according to your requirement, you can download your file. Okay, and then under edit menu, you have a number of options. You can just go and explore. So the important one is, if you want to know about the shortcuts that are available in the Python Jupyter notebook, you can go and explore what are the shortcuts available here. Okay, what are the keyboard shortcuts? You can just go and learn. Otherwise, you will find online the cheat sheets for the shortcuts. Okay, you can download them, and you have it ready for quick reference. Okay, so now this is the kernel. Okay, I told you already, kernel is responsible for running your command. So you can, supposing some commands, say for example, in the pair plot in visualization, the pair plot takes quite much time to run if your data set is large. Okay, if the number of columns are quite large, then it takes considerable amount of time to give the result. So if you don't want to wait, and if you want to interrupt the kernel, and then if you want to kill it, all those you can do by clicking on this kernel menu. Okay, right. And then as I already told you, you can run one cell or a multiple cells, anything if you want, you can do. So if you want to insert a new cell below or above, you can do that. Okay, so these are all the important items under the menu. Right, and then I have created the contents by using the hyperlinks. So it is easy to understand. Say something similar to the format in HTML. I create a hyperlink in which this is the bookmark that I have created below. Okay, so what happens if I run this? The hyperlinks are created. So once I click on a specific link, it takes me to the specific location. Okay, right. Now initially I have to import the necessary libraries and load the data set that we are going to handle as a pandas data frame. Okay, so now what I do, I use the pandas library. I import the pandas library as PD. PD means like I just want to give an alias name for the pandas library, because every time I don't want to use it as, every time I don't want to use it with the full name pandas. Instead, I just want to give an alias name. So if I say import pandas as PD, it means I am giving an alias name for, supposing if a person has an alias name, I can call the person with the original name or with this alias name, right? Similarly, I, instead of calling the library with the original name pandas, with the full name pandas, I just want to call it with the shortcut name, shorter name PD. Okay, this is an alias name, right? And then similarly, I just want to import the Seaborn library as the alias name that I want to give as SNS. Okay, so there is an explanation like this. In the year 2000, there was a popular TV show with the name The West Wing, in which there was an actor with the name Seaborn, who is called with the shortcut name SNS. That is the reason why, even though there is no S at the end, that is the reason why the general shortcut, you could use XYZ anything, but generally they use the name SNS, but you can use, it's just an alias name. You can use any name as per your wish. Okay, it is not that every time you will have pandas as PD and Seaborn as SNS. It is not like that. It is user defined alias names. You can use any name as per your wish. Okay, and similarly, as I told you, pyplot is a sub package of matplotlib. So how do I access it? Import matplotlib.pyplot, and then I'm giving a short. Otherwise, what I have to do, every time whatever command I use from pyplot, I have to give the entire name like this. Okay, so instead of that, I just want to use a shorter name PLT. Okay, and the fourth one is I just want to set the color codes as true, because it just adds a nice background to your graph. Okay, and then if you want to display all your graphs within the Jupyter notebook, then use this command %matplotlib inline. This inline command help you to display all the graphs, whatever graphs you are making it inside the Jupyter notebook itself. Otherwise, if you don't do that, only an object for the charts that you are creating will be created. Okay, and it won't display. The graphs won't display in the Jupyter notebook. Okay, so and then the later I just want to import, I just want to download the file, download the data set, which is in the format of a CSV file. The CSV file, you must be knowing, any structured data can be represented using the format of a CSV file, in which all the column values will be separated by a comma. Each column value will be separated by a comma. So I'm using a data set called automobile.csv. Okay, so this I'm reading it as a pandas data frame. Okay, so the command for using the command for creating a pandas data frame is pd.read_csv, because I want to create a data frame from a CSV file. So the function that I will use is read_csv. Okay, so from this CSV file, I just want to create a data frame. So now this variable auto is a data frame. Okay, so now I just want to see the first top rows. So it will display the first 5 rows for me. So if I say auto.head, it will display the first 5 rows. Okay, now there are 26 columns in this data set. If I just want to know how many records are there, how many observations are there, I can say auto.shape. So there are only 201 records. There are only 201 records, and there are 26 columns. 201 rows and 26 columns. We have just displayed the top 5 rows here. So if you see here, the index ranges from 0 to size -1. So since there are 201 rows, so the index ranges from 0 to 200. Okay, so if I want to know the column names, I can scroll here and check. But here some of the columns are missing. It is not shown here due to this limitation in the size column width. Okay, so if I want to see all the names of the columns, I can use a command called auto.columns. This is displaying me all the column names in my data set. So this data set is about the information about certain vehicles, whether two-wheeler or four-wheeler, what is the make of the vehicle, and what is the fuel type, whether it is diesel or petrol. Okay, so and then what is the body style, how many wheels are there, where is the engine location is in the front or rear, what is the engine type. Okay, so all those information are available in this particular data set. Horsepower, what is the miles per gallon in the city, what is the miles per gallon, what in the highways, what is the price, all those information are available in this particular data set. Now if you want to perform univariate analysis on the numerical columns, then we can go with histograms or distribution plots. So initially the syntax was, we are using the Seaborn library for creating a distribution plot. This is either you can go for a histogram from a matplotlib. Okay, you can use plt.hist, which will plot the same thing. Okay, the distplot is another name for the histogram supported by Seaborn library. So SNS is an alias name for Seaborn. So I say sns.distplot for whichever column I want to see the distribution. I have to mention it as an argument here. So the name of the data frame is auto, and I want to see the distribution for the column highway underscore MPG, means the miles per gallon in highways. Okay, so if you see here, the distribution plot is something like this. So from this distribution plot, you can understand, you could see the histograms also. Okay, and from this distribution plot, what you can understand, this is somewhat a normal distribution, but there is a skewness on the right, a little skewness on the right, but generally it follows a normal distribution. From the graph, you can understand it follows a normal distribution. Okay, so what you can do is you can also you can remove, that means the kernel density estimation, you can make it false, therefore you will not see this, this particular line graph. Okay, only you will see the histogram. And then if you say RAG is equal to true, the individual values will be shown, okay, along the x-axis. If you want to see the individual values along the x-axis, you can see it by setting the RAG property to true. Okay, right. So this one is for highway underscore MPG. I have created a plot, and this one is for city underscore MPG. And similarly, the box plot. The box plot gives me a number of information like what kind of many of the statistical information it gives me. What is the minimum value? What is the maximum value? What is the first quartile, second quartile, third quartile values? What is the mean? What is the median? All those statistical information I can get from a box plot. Okay. So again, I am using the highway underscore MPG column to create a box plot. So if you see here, this is a box plot. So this is the 50th percentile, which means 50% of the records are in this area, and 50% of the records are in this area. Okay. So on the right to the 50th percentile, 50% of the records are onto the right. Okay, so you could see from 50th percentile to 75th percentile, there are only it is lesser than 25 to 50. So this is the 25th percentile. This is the 50th percentile. Okay, so there are more number of records. There are more number of observations between 25th to 50th, and then little lesser than 50th to 75. Okay, and there is a value called interquartile range. So mainly the box plot is used for detecting the outliers. Means the meaning of an outlier is any data point that is not matching with, that is not going in the same region along with the rest of the observations. Okay, so here how to detect the outliers in using a box plot is any point that is greater than Q3 plus 1.5 times IQR. IQR is interquartile range, which means interquartile range is equal to Q3 minus Q1. Q3, this is Q3, this line is Q3, third quartile means 75th percentile. This is Q1, first quartile, which is 25th percentile. This one median is 50th percentile. Okay, so any data point which is greater than Q3 plus 1.5 times IQR will be treated as an outlier. Similarly, any point which is less than Q1 minus 1.5 times IQR will be treated as an outlier. Okay, so a box plot is a very good tool for detecting outliers in your data set. Okay, so so this is a very important plot. Through box plots, you can easily understand the presence of outliers. So once you find, because if you are going to create any machine learning model with a data set containing outliers, then it is not going to perform well. Okay, you will not get good results while building a machine learning model that consists of outliers. Okay, so before building a machine learning model, one of the pre-processing step is to remove the outliers from your data set. Okay, so box plot is very useful in identifying the outliers, and then you will take the appropriate measure to remove the outliers. And then in case of a categorical column in which the column takes categorical values, I can even show the data set in the Excel sheet, so that what is the meaning of a categorical data, the categorical column, you will be able to understand. See here, the fuel type is a categorical column, which means the possible values for fuel type is either gas or diesel. Okay, and make is also a categorical. What is the make of the car, make of the vehicle? Okay, so that is also a categorical column. But normalized losses is a numerical value, numerical column. Okay, and the number of doors are going to be 2 or 4. Okay, again a categorical column. So if you want to visualize the data that takes categorical values, then you have to use different kind of plots. So the best plot would be a count plot, which will show the number of observations corresponding to each value in the categorical column. Supposing the number of doors takes a value either 2 or 4, right? So in that case, how many observations are having the value 2 for the column number of doors? Okay, how many observations are having the value 4 for the column number of doors? That is what you can infer from plotting it. Okay, so here I use a count plot. I pass the body style. Body style is again a categorical column. The different values are convertible, hatchback, sedan, wagon, and hardtop. Okay, so if you see here, there are around 85 to 90 observations with a value sedan for body style. Okay, similarly, there's around 65 observations with a value hatchback for body style. Okay, that is what you can understand from this count plot. Okay, so you can use any kind of categorical variable here to understand your data. Okay, and then I use a line plot again. Okay, so the line plot, if you see here, I use the PLT, means the alias name for PyPlot library. Okay, I just want to increase the figure size. If I don't use this, what happens? If I don't use this, it will take a default size and then the figure would look very small. So this is fine now. Supposing if there are more number of categories here, then within this fixed size, you will not be able to visualize it properly. There is a reason why I just want to specify manually the width and height. Okay, so width is going to be 12 and height is 4. Right. Okay, and here I plot the line plot on the column make. Okay, so this value counts will give me how many records are there for each category. Okay, and then I sorted by index and then plotted. The type of plot is line. Okay, and then area plot. Area plot is something similar to line plot, but the underlying structure would be shaded. Okay, so the syntax is going to be same, but instead of line, you will say area. So if you see here the pie plot, I'm going to show you the pie plot. So for that, I'm going to use the number of doors attribute. Okay, the number of doors attribute. So here again I check the value counts. So the output of value counts is a function. Value counts is a function which will give me the number of records belonging to each category. So for the column number of doors, the total number of records are 201, right? The total number of records are 201. There are 114 observations that has a value 4 for number of doors. Okay, and there are 87 observations. There are 87 rows that has a value 2 for number of doors. Okay, so how can I plot it as a pie plot? So I set the labels as number of doors dot index. Index is this 4 or 2, and then the values are 114 and 87. Okay, so it will actually show me the percentage. It will actually show me the percentage. Okay, not the actual number of records. It will show me the percentage. So there are 56.72% of records having the value 4 and 43.228 number of records having the value 2. Okay, so that's how you can plot a pie plot. And then how can you perform bivariate analysis? So in case of bivariate analysis, you can compare two numerical columns. So in that case, you can go for a joint plot or a scatter plot or a pair plot, and also for a linear regression model plot. Okay, so how to plot a joint plot? So again, I'll use a Seaborn library dot joint plot. So I'm going to have the visualization between two columns, which are engine size and horsepower. Both are numerical columns. So engine size is also a numerical column. Horsepower is also a numerical column. So if you see here, the advantage of joint plot is, unlike the scatter plot where you will see only the scattered points, the joint plot also gives you the histogram. So this is the histogram for engine size, and this is the histogram for horsepower. Okay, so that is also being provided in joint plot. So what is the syntax? You will say SNS.joint plot. Syntax is very simple. Okay, engine size and horsepower. Right, and then so from this, what do you understand? From this, what do you infer? So just I have explained the syntax of using joint plot. From this graph, what do you understand? So there is a linear correlation between engine size and horsepower. If the engine size increases, horsepower also increases. Okay, so there is a really a linear relationship between engine size, positive linear relationship between engine size and horsepower. Okay, that is what you can infer from this. And then how you can make hexagonal bin plot is just by using mentioning the kind as hex. Okay, the same plot, instead of using the dots, you are going to use hexagons. So the color of the hexagon represents how many points are there in that particular location. If the color is very dark, it means there are so many points here. Okay, if the color is very light, it means there are less number of observations, less number of points here, data points here. Okay, so that is a hexabin plots where you will just mention the kind as hexagonal, kind as hex. Okay, so the color indicates the number of data points at that particular location. This is something similar to the scatter plot. And then you will use you can use the kind as, you can mention the kind as KDE. KDE stands for kernel density estimation. Okay, the same thing, instead of having the histogram, you are having a distribution plot. Okay, so if you see from this distribution, I'm sorry. So from this distribution, what you understand, this particular engine size column is skewed to the right. It's a skewed data. So again, for building machine learning model, you have to be very careful that you cannot, the skewed data always give some wrong predictions or wrong results. Okay, so you have to fix this. This is called as imbalancing of data. Okay, data imbalance means there are some records which contain that is about the target variable, so which we are not actually discussing in detail. So you have to take care of the skewed data. Okay, so in those steps you will learn under data pre-processing how you can handle the skewed data. Okay, and then the scatter plot, how we can make a scatter plot, as I told you already. Unlike the joint plot where you also see the corresponding histograms here and here, okay, horizontally and vertically. The scatter plot displays only the points scattered around. So from this image, you can again understand there is a linear relationship between horsepower and price. What kind of linear relationship? What kind of a linear relationship here? Is it positive or negative? If the horsepower increases, price also increases. Is it a positive relationship or negative relationship? This is a positive relationship, okay? If the horsepower increases, price also increases, then it is a positive correlation, is it not? Okay, so it's a positive linear relationship. Supposing if the horsepower increases, if the price decreases, then you will say if the trend is like this from top to bottom, okay, like this through the left diagonal, then you will say the relationship is negative. Okay, and I have an example for that, I guess I'll show you. And then the pair plot is a very useful plot in which you can quickly understand the relationship between all variables that are available in your data set. Okay, pairwise. Okay, so it will consider all the columns in the data set. Now I'm not displaying all the columns here because it's a very huge data set, means containing huge number of columns. It will take so much time to load the pair plot. So I just use only 3 columns, and again pair plot will work only on numerical columns. So in my data set I have some categorical columns too. I have just chosen few of the numerical columns: normalized losses, engine size, horsepower. All the 3 columns are of numerical type. Okay, so what I'm going to do, I say SNS.pair plot, and then since I have a number of columns here, I enclose them in the double brackets. I enclose them within double brackets. Okay, so if you see here, this is normalized losses to normalized losses. Okay, so I'll get a histogram. But for other, this is engine size to normalized losses. So this plot represents the relationship between engine size and normalized losses. So this is between horsepower to normalized losses. Okay, this is engine size to horsepower. Okay, so what happens for the same variable? It will show you a histogram. So if you want to mention the type as, if you also want to see the distribution plot, supposing in case of unsupervised learning techniques, in which sometimes you may have to, you may be interested in finding, let me try, kind equal to PD. You may be interested in finding the number of groups in your data set. This is not okay. Once again, is there any syntax? Actually, instead of only the histogram, you can also have, I think, there's just missing some syntax. Okay, you will also get, I told you, no, the pair plot takes some time. Okay, so you will get also the kernel density estimation, which means the distribution plot also you will see. Okay, and then the line plot, not line plot, linear regression plot. So once you have a scatter plot like this, and if you want to find a line that optimally fits all the data points, best fit line, if you want to find a best fit line, linear regression line, then you will go for SNS dot linear model. LM plot stands for linear model plot. Okay, linear model plot. And then the column that I'm using is horsepower and engine size. Okay, so if you see the syntax here, so for any library function, if you want to see the syntax, you can press Shift plus Tab. If you want to know the syntax of this particular So I'm not finding the documentation for this. So to see the documentation for any built-in function, you will press Shift plus Tab so that you will know the syntax for the specific function, and then you can understand the arguments given to it. So here you can, since you are specifying x is equal to this and y is equal to this, you can specify in any order. Supposing if you don't want to specify x is equal to this, y is equal to this, and simply you are specifying engine size, horsepower, auto, then automatically it will assume x is engine size, y is horsepower, and the data set is auto. Okay, so that is how you can mention. Otherwise, if you want to change the order, then you have to specify the name of the argument followed by the value, right? And then the same thing, now I want to have the hue as fuel type. So what happens? For each fuel type, it is going to give me a separate best fit line for each fuel type, because I mentioned the hue as hue, meaning of hue is color. Okay, so for each the best, it is showing me a best fit line for each fuel type. So there are two fuel types, one is gas, another one is diesel. So it is showing me the fuel type, the best fit line for each fuel type. And then if I want to have a bivariate analysis on a categorical column and a numerical column, then I can go for any of these plots: strip plot, swamp plot, box plot, bar plot, point plot. Okay, all these plots we are going to see one by one. Now, so the strip plot, if you see the syntax, SNS.strip plot, the name of the data means the column. This is going to be the column X, and this is going to be column Y. As I just now I told you, right? If you are going to specify the name of the argument followed by the value of the argument, you can specify in any order. If you don't specify the name of the argument, then by default the first argument is the. Let me check now whether it works for the documentation is available for this function. I think, Okay, so now I just want to have in x-axis fuel type, and then in the y-axis horsepower. Okay, so fuel type is two different values, gas, and so this is a categorical column, this is a numerical column. Horsepower is a numerical column, fuel type is a categorical column. So if you see here, you are not able to still identify how many distinct points are there, right? You are not able to identify how many distinct points are there. So you can go for a swarm plot. In that case, you will be able to see all the points. Okay, since it's a categorical column, it will try to plot. You cannot change the value for horsepower, but since this is a categorical column, it is able to segregate the points and show. The swarm plot is able to segregate each individual data point, and it is able to show us how many values or how many data points are there in this particular point. Okay, so there are many gasoline vehicles which with a horsepower value around 60 to 70. So okay, so this is approximately value 70, 65 if I am going to assume. Then there are many observations. There are many gasoline vehicles with a horsepower around 65. So that is the meaning of this. Okay, there are many diesel vehicles. There are few diesel vehicles. There is only one diesel vehicle with a horsepower around 112 or 110, whatever it is. Okay, right. So there is a meaning of this. There is a usage of swarm plot. You will be able to see all the data points individually. Even the strip plot is not able to show us that particular information, right? So you could see only a cloud of points here. The points are being overlapped, but here in swarm plot you are able to see all the points individually, right? And then the box plot, again I have shown you a box plot for univariate analysis. You can also use box plot for bivariate analysis. Now I use box plot for number of doors. Here number of doors is what kind of variable? Is it a categorical variable or numerical variable? Even though it is going to take the values 2 or 3 or 4, even though the values are given in numbers, Okay, but here the values are given in text. Okay, 2, 3, 4. The values are given in text. But even though if you are going to give the values in numbers, okay, are we going to consider this particular column as a numerical column? No, because it is taking distinct values 2, 3, 4. Okay, so in that case, we consider it as a categorical column, not a numerical column. Numerical column is something like salary, okay, rent or price, something like that. Okay, so that means the column is going to take values from a range of values. It is going to take value from a range of values. So that is what we call it as a numerical column. But here, number of doors is a countable number of values, right? Countable number of values. So here, either the value 2 or 3 or 4 is are the values given here. So there are only 3 different possible values for number of doors. I think only 2 values, 2 and 4. I'm sorry, only 2 and 4. So in that case, it is a categorical column. So I just want to have a box plot for number of doors and hours per. So if we see here, okay, number of doors are only 2 and 4. Okay, so the hours per. So if you see here, there are few outliers. Okay, there are few outliers. So what do you understand from this? The data is actually skewed for the number of doors is equal to 2. There are many observations. There are many records after the 75th percentile. Okay, so here data is also skewed as well as there are some outliers. Okay, that is what you can understand from this box plot. So once you visualize the data and you identify the presence of outliers, if you identify the presence of skewness in your data, then you will go for the pre-processing of your data where you will try to fix all those issues. Okay, we are not going to discuss about the data pre-processing steps here. So again, here I use a hue also. So when I use a hue as fuel type, okay, which means I'm just trying to have the same information, but I just want to segregate it based on fuel type. Okay, there are a number of cars with the number of doors is equal to 2, and there are a set of cars with the number of doors is equal to 4. Again, I want to categorize them based on fuel type. Okay, so I could see there are many blue color stands for gas. Okay, so that there are many gasoline vehicles compared to diesel vehicles with the number of doors is equal to 2. Okay, but if you see here again here with the number of doors is equal to 4, the number of gasoline vehicles are more than the number of diesel vehicles. Okay, so that is what again there are some outliers because it is the same plot, just you have used the hue, you have used fuel type as the hue. That is the difference. Okay, and then the column plot or bar plot, you can use a bar plot. So we can plot the mean of a data set separated in categories. Okay, so again I'm using the hue as fuel type here. So this bar plot is a plot between body style and horsepower. Body style is a categorical column and horsepower is a numerical column. Okay, and again I use the hue as a fuel type as a hue. Means if I don't use this, what will happen? I will not have the segregated information. Okay, I'll have only for the information available for body style and horsepower. For the body style is equal to convertible. I just want to again segregate based upon the fuel type. In that case, I will use a hue attribute. I'll use a hue attribute. That is a usage of hue. You understand the difference between using hue and without using hue? What is the difference? Okay. So that is about bar plot. So depending upon your problem statement, whatever kind of analysis you want to make, you will choose the appropriate plot. Okay, again, I just want to use a count plot for bivariate analysis. This is a count plot. Already we have used a count plot, but for univariate analysis, again it is a univariate analysis, but here I use a hue. That is the difference. Earlier I have shown you a count plot, right? I have shown you a count plot here. Where is it? this is the count plot. Okay. Count plot for body style. How many number of records are there for each body style type? Okay. But here in this, I'm using the hue, the color. Means I just again want to segregate based upon fuel type. Okay, the same information I'm getting it. Okay, but this time for each body style, the information is segregated based upon the fuel type. So what information you infer from this graph? For the body style convertible, there are no diesel vehicles. There are no diesel vehicles in which the body style is convertible. That is the meaning here. Okay, there are only very few vehicles, very few diesel vehicles with body style hardtop. Okay, and there are many number of comparatively many. Okay, comparatively many. Again with the hatchback. Okay, with body style hatchback, there are very less number of diesel vehicles. So comparatively, there are more number of diesel vehicles with the body style saddle. That is the meaning that you can understand from this. Okay, and then going for the point plot, again we are going to use one categorical column and one numerical column, and I use number of doors as the hue. Okay.
Hello, ma'am.
Yeah.
Hello, ma'am.
Yeah.
Ma'am, I have a doubt regarding this.
Yeah, tell me.
Hello.
Yeah, I can hear you.
Ma'am, from where I can download this Python? Ma'am, is it necessary to download this Jupyter to use this Python?
Yeah, if you want to run the code, you have to download the Jupyter notebook from Anaconda distribution. It is very simple. You just go to the website, Anaconda
Okay,
website. You want me to show?
Ma'am, when I have downloaded Jupyter.
Yeah, tell me.
Ma'am, some files are not importing. Said there is these files are not importing. From how we import those files?
Which files?
Ma'am, whenever I use some ML commands, so import files mathematics key.
You have to import the appropriate library. Okay, so for running this code, I have imported the libraries because I'm using some of the commands that are available under the library pandas. Similarly, for visualizations, I use the libraries cban, matplotlib.pyplot. So if you are using for any function or any method that you use, you have to download the appropriate library like this using the import statement. So with the Anaconda distribution, these libraries are available by default. Okay, if you are getting a message saying that this particular library is not available in your Jupyter notebook, then you can download them using the command. Yeah, one second. Exclamation PAP. Okay.
Yes. Yes, ma'am.
Okay, and then you specify the appropriate. I'm not sure about the exact syntax, but I can share in the PPT. Okay, so you will use the pip command to download the appropriate library, whichever library is missing. Okay, I think.
Okay, ma'am. Thank you, ma'am.
Import and then specify the file library name if you want to download. Matplotlib comes along with the Anaconda distribution itself. Supposing if you want to import linear regression or if you want to import keras, some libraries. Okay, so you can do it like that.
Thank you, ma'am.
I'm not sure. I forgot the exact syntax, but I know this is the PAP command is the command that you use for downloading all the libraries to your Jupyter notebook from the Python package. Okay, but the import command I have to check once again. Not import. I'm sorry. Install. PAP install. Yeah, I got it. Okay, so appropriate.
Thank you, ma'am.
Yeah. Okay, anything else? Shall we go ahead? Shall we proceed to the next one?
Yes.
Okay.
Hello, ma'am.
Yeah.
Hello, ma'am.
Yeah,
Ma'am, can we implement all these in Colab, ma'am?
Yeah,
All these
Colab
plots?
can use Colab also, but some of them might be finding it difficult because Colab is not actually required. Colab is for
Yes, sir.
running your code using a GPU, graphical processing unit, which is
Yes,
which is
ma'am.
for generally for deep learning models. If you are building deep
Oh,
learning models, you will go for, because it is going to occupy so much of your processing power. Okay, so these are all
oh,
simple commands which we can very well run in CPUs. Okay,
okay,
so if
okay,
you have
ma'am.
already
Okay,
installed the Google Colab, then you can run on Google Colab, no issues.
okay, ma'am. Thank you.
Okay, so Google Colab, it is easy for you because you don't need to download Jupyter Notebook. In Google Colab itself, it's available. The only thing is you should know how to do the preliminary steps to set up your Google Colab. That's it. Okay, and then the point plots. Again, I use body style and hotspot, and then I use the number of doors as hue. So if you see here, the point plot also gives me the blue color is for 2 doors vehicles, and orange color is for 4 door vehicles. Okay. So, and then the multi-panel categorical plots. I can use a cat plot. So here I'm going to have multiple categorical variables. So here in x-axis I'm going to have the fuel type, and in the y-axis horsepower. Okay, and also I can mention the columns. Means based on the drive wheels, I want to have multiple plots in the same graph. I just want to have multiple plots. So the columns are defined by the values for drive wheels. So drive wheels is a categorical column which takes different values like RWD, FWD, okay, 4WD, okay, 4-wheel drive or rear wheel drive, or I'm not much good in knowing about the cars. Okay, so it is taking 3 different values for the column drive wheels, number of wheels, not the number of wheels, what kind of whether it's a 4-wheel drive or it's a general car, something like that. Okay, so there are three distinct values for drive wheels. So accordingly, there are 3 plots in the same graph. In the same chart, I'm able to visualize 3 different plots. That is what I'm trying to explain here. So, and the kind of plot I'm choosing is box plot. You can use any kind of plot here that I have mentioned here. You can use a point plot, or you can use a cone plot. So you can change the type to be point. Anything you can use. Okay. Or you can use point plot. Box plot was much meaningful. Or you can use violin plot even. That is more. It is different, so you would have a different kind of plot. So violin plot, okay, and you can also use bar plot. Any kind of plot you can use. Something like this. So that is about the different type of categorical data. Any doubts? If you are interested, I can show you some more. With another data set, I can show you the graphs which are used for EDA, for performing EDA, exploratory data analysis. Okay, so here the data set that I'm using is the bank database, in which the bank is trying to sell the term deposits to their customers. Okay, so there are a number of columns here: age, job, marital status, education, whether the customer has a credit in default, okay, whether he has got a housing loan, whether he has got a personal loan, what is the balance amount in his account. So all those are the column names. And again, there are some more relevant columns like how the customer has been contacted in the previous venture, for term deposit sale. So for any for building any machine learning model, you need to have the domain knowledge. Supposing if you are doing a project in bank, or if you are doing a project in finance, if you are doing a project in e-commerce, you need to have the domain knowledge. Then only you can understand the data very well, and then you can go for visualizing them using the suitable plots. Okay, so here you try to read the column names, and also any data set that you download from Kaggle, or if you are working on a research project, if you want to have a suitable data set, you can go and search in Kaggle. You will find all types of data sets. Okay, if you want to see along with the implemented code, you can go and check in GitHub. Okay, where you will find the code also. So whenever you are going to download a data set, it will come along with the description of the data. Okay, so this is the description I got about the data set available along with the data set itself in Kaggle. Okay, so those are providing the data set will also give the in the README file, it will be available, or separately description will be available. Okay, so you can try to understand the meaning of each column, then only you will be able to plot meaningful graphs. Okay, so this is related to previous contact. So during the previous sale, how the customer has been contacted, that is the meaning of the column contact. Okay, how through which medium the particular customer has been contacted, during which month the customer has been contacted, okay, previously, and which day of the week he has been contacted, during day 1 or day 2 or day 3, whichever day of the week the customer has been contacted, and how much time the call duration was. Okay, it is indicated in seconds. Okay, and other attributes include the campaign, means the number of contacts performed during this campaign and for this client. Okay, so during the current campaign, how many times the customer has been contacted, and the P days represent the number of days that passed by after the client was last contacted. So how many days has been passed after the customer has been contacted previously, that is the meaning of P days. And the previous is whether number of contacts performed before this campaign. Okay, before the current campaign, how many times during the previous campaign, how many times the customer has been contacted, and what is the outcome? What is the outcome of the previous campaign, whether he has accepted for the term deposit, for subscribing for the term deposit or not. That is the outcome of the previous campaign. So the meaning, if he has already accepted for the previous campaign, now during the current campaign, the same customer need not be contacted, right? And the desired output variable is, in case of predictive analysis, you will have a set of columns and you will have a target column. So the set of input columns, they are otherwise called as predictors, are dependent variables. Okay, so based on the values for these dependent variables, you will be able to predict the value for the target variable. Okay, so that is the predictive modeling. That is predictive modeling, mostly under that comes under supervised learning technique, where you have a collection of input variables and then you will have one output variable. Okay, and you will be able to predict the value of the output variable based on the values given for the input variable. Okay, that is the meaning of predictive analysis or supervised learning technique. In case of unsupervised learning technique, you will not explicitly have an output variable. Instead, you want to identify some groups that is present in the data. Yes, anything? Any issue? Okay, okay, right. Now, I just want to import again. I just want to import the necessary libraries, and then these are all some of the exploratory data analysis, non-graphical exploratory data analysis. So when I want to move to the graphical, means the graphical visualizations. So if you see here, I'm using code, some code in which I just, in a single graph, I want to have a number of plots. Okay, in a single graph, I just want to have a number of graphs. So if you see here, I'm declaring a figure, and then I'm declaring the 3 axes, axis 1, axis 2, axis 3. I just want to have 3 subplots in one graph. I want to have 3 subplots in one graph, and I specify for a list of columns, I just want to have graphs, visualizations. Okay, for the column age, I just want to have a box plot, as well as I want to have a distribution plot, as well as a histogram. Okay, so for the same variable, for the same column, I just want to have 3 different kind of analysis, 3 different kind of visualizations. Okay, so for that what I do, if you see the code here, I'll be able to create multiple plots in a single chart itself. Okay, how I'm doing that? I'm declaring a figure and then I declare axis, 3 axes, axis 1, axis 2, axis 3. I'm sorry. See here, and then I say PLT dot subplots. What is PLT? PLT is the object of pyplot. Means the alias name for pyplot. Okay, pyplot is a sub package of matplotlib. Okay, so matplotlib dot pyplot, that I call it as PLT. Okay, and then there is a function called subplots in which I just say 1, 3 and the figure size is 13, 5. I just want to have the width as 13 and the height as 5. Okay, initially in the axis 1, I just want to have a box plot. So they each. What is the meaning of each? I'm using a for loop here. If you are familiar with the syntax of writing a for loop in Python, you will be able to understand this. The syntax for writing a for loop in Python is for some variable in columns, mean in another variable. Okay. So I just say each is just a variable name. Okay, you can use anything here. Okay, for each variable, for each value in the variable columns. Columns is a list. Okay, it is a list of values. I can create a list using square brackets. So here I created a list. So this variable each is going to take values from this list. Okay, so every time I mention each, during the first iteration it will point to age. During the next iteration it will point to balance. During the third iteration it will point to duration. Okay, that is how it will work. Okay, so what I say, x is going to be, x-axis is going to be the column name, age. Okay, and the data set is going to be bank df. Okay, it is a data frame, and then the orientation is vertical and axis is axis 1. In axis 1, I just want to have a box plot. I just want to have a box plot. And what is the label? I just want to set the label, x label as each. What is each initially? During the first iteration, the x label is age. Okay. And what is y label? Y label is also, because it's a univariate analysis, right? Both x label and y label I set as the column name. Okay, because it's a univariate analysis on a single column. And then the parameters. Tick params means the values that you want to mention in the x-axis. Okay, so I just mentioned the label size as 50. Okay, so what will you see here? If I want to show, and then once again let me show you the code for second axis 2. In axis 2, I just want to have a dist plot. Okay. Again, the x label is the name of the column. Okay, you can also set the y label. Right. The syntax is simple, and similarly the same syntax for creating a histogram. Okay. The 3 different syntax I have shown. So here using sns.distplot, here I say axis3.hist. Okay, I use the hist function, and then I just want to plot each column on the bank data frame. Right. So if I see here, if I look at the graph, what will happen? Can you see the graph? Because I'm not. Can you see the graph? Some windows are hiding the graph for me. I hope you are able to see the graph. Okay, for each column that I mentioned in the list, I'm able to see 3 different plots. Box plot in axis 1, dist plot in axis 2, and histogram in axis 3. Okay, this is how you can plot multiple. You can create multiple plots in the same graph. Okay, and then this will come under EDA. I'm showing only the visualizations, not the non-graphical understanding of analysis of data. Okay, so now if you see here, I just want to create a count plot. Okay, for n number of variables. So instead of writing the code n number of times, I simply use a for loop. I mentioned all the columns in which I want to have for which I want to have a count plot. in a list. Okay, for all these columns are categorical columns. Okay, for all these categorical columns, I want to create a count plot. Okay, so what I do, all the categorical columns, I put it in a list and call it as columns. This name of the list is columns. And then I say for I in columns. In the previous code, I used the user defined the variable each, right? Here I say I, anything. It is a user defined name. You can use anything. Okay, and then again I want to create subplot. Each time I just want to have one plot, not three plots. Earlier I said subplots of 1, 3 because in each row I wanted to have 3 plots. But here in each row I just want to have only one plot. But the figure size is 15, 5. Means width is 50, height is 5. Okay, and then the count plot x is 5. The x-axis I mentioned the column name. I represents the column name, right? So initially during the first iteration, it will work for the column job. The first column is job. The data set, the data frame is, name of the data frame is bank BF, and I just want to count the number of records based on the column values. Okay, I'll group the record count based on the column values. Okay, so what happens here? Here the job type is blue collar, management, technician, admin. So if I see here for each of the column values, the count means the number of records in the data set. So from this data set, you are able to easily understand that there are many records, there are many customers in the bank whose profession is, he is a blue collar worker. Okay, many customers in the bank are blue collar workers. And what is the least count here? From this, what you understand? There are some customers who are students. Okay, in the bank. So the bank has got some customers who are students, and from this unknown, what you understand, there are some missing values. Means there are some records for which there is no information on the job. Okay, this you will, even though the value is given as unknown, this you will treat it as a missing value. Okay, because it is not a meaningful value for job, right? So instead of keeping it as blank, they have given the value as unknown. Okay, so this is a missing value. So again, you have to treat how to eliminate the missing values, how you have to handle the missing values, you have to do during the pre-processing step. Okay, so if you see here, as I already told you, pair plot can work on all the columns in the data set. Okay, so here I use the bank DF. I simply give the name of the data frame and then I just want to plot. So what happens here, you could see for all the columns pairwise. So this is below diagonal and above diagonal are same kind of plot, but it is in the reverse order. Okay, either you can consider the graphs below the diagonal or the graphs above the diagonal. Only the axis switches. The axis switches. Okay, changes. Okay, x becomes y, y becomes x. That's it. Okay, this is the pair plot, and similarly. This is an example that I wanted to show you for how you can create multiple plots in a single graph using the for loop or any kind of looping structure. Will be the function for creating multiple plots in a single graph is subplots. Okay, 5 plots subplot function help you to create. Yes, any doubts? Any doubts?
Ma'am, you can continue, ma'am. At the end of the section, you have to ask the question.
Okay, I thought somebody is trying to ask some questions. Okay, so
Okay,
this is what you have to understand by visualizing. It is not that simply you will use the syntax and then use the name of the graph and then plot it without. So generally, the Jupyter notebook, why we use, instead of using a Python command cell, why do we use Jupyter notebook is you can tell a story here. As a data scientist, you must be able to tell a story, what you have understood, how you are going to process the data, what are the pre-processing steps you are going to take. From data non-graphical visualization and graphical visualization, what inference you are making out of the data. Okay, so all those things you have to write step by step, so that anybody who reads your notebook, who reads your work will be able to understand, must be able to understand what you have exactly done. Okay, so only in the Jupyter notebook you have the features to include some comments like this, some description, some meaningful and wonderful descriptions you can include, which are aligned in a perfect manner. Okay, so for anyone who is going to read your notebook will be able to understand what you have exactly done, how you have visualized the data, what kind of visualizations you have done. Okay, what is the inference you are making out of the visualizations, and how you are going to deal with missing values, how you are going to deal with outliers. If you are finding skewness in the data, what is the step you are going to take? If you are finding imbalance in the data set, how you are going to handle it. All those information you have to mention, so that anybody who is going to look into your notebook must be able to understand what you have exactly done. Okay, the final conclusion you have to include. Okay, there are also some case of a pre-processing, you will have to change the categorical data into numerical values, okay, using one-hot encoding or label encoding. So all those concepts you will have to understand. So the pre-processing step is a step after data visualization. Okay, so this is a very basic step in handling the data for a data scientist. That's it from my side. If I'm open for questions.
Participants, if you have any queries, you can post in your chat box, or you can unmute your audio and you can ask the question. Dr. Sophia, ma'am, you have given a question. If you can unmute your audio and you can ask the question.
Ma'am, already I have clarified that with her, ma'am, regarding the collab. And just I would like to know the steps that you have performed before data visualization. Just if you scroll slowly, just we can have a glance over it. That's where I was asking for.
Which one, ma'am?
Ma'am, actually, before data visualization, in this EDA process, you had some previous steps, no, ma'am? Basic steps that you have performed.
Yeah, this is the actually EDA. It makes use of some of the visualization tools and non-visualization tools for performing EDA. Okay, so
Yes,
in
ma'am.
EDA, you will use both graphical tools as well as non-graphical tools for understanding your data. So today's topic today's topic is about visualizing the data. Means the graphical tools that are available in the Python package, using which you can try to understand the data. That's what we have. There are some non-graphical tools too. Okay, means some of the functions using which you can try to understand the data that is also being available under EDA, but I'm not showing them today.
Okay.
Anything else?
Thank you, ma'am. Ma'am, I have a question, ma'am. What's the difference between using the strip plot and the scattered plot?
Which plot? Strip and
The scatter.
Scatter plot and strip plot. I told you, right? Scatter plot cannot show if a data point lies in the same location. You cannot distinguish between if there are multiple observations in which when you plot the data point, if it is taking the same location, you cannot segregate. Okay, I'll show you here. One second.
Okay.
See, scatter plot. See, there are, in case of a strip plot, this is a strip plot, okay? This is a strip plot. There are many observations here. There are many data points here. But in case of a scatter plot, you could see all the points will be shown as only one single point. Okay, so here in the scatter plot, you will not be able to understand how many distinct data points are there in a specific location. Able to follow what I'm saying?
Yes,
but
ma'am.
in case
Understood.
of a strip plot, it is going to segregate the data points horizontally, not vertically. Okay, if it is going to segregate vertically, the meaning will differ. Okay, since it is a categorical column, if I'm going to have a horizontal if I'm going to say plot the data points in the horizontal axis, okay, the meaning is not different because for all the data points, the horsepower is same. Okay, there are many data points at this location. So in this, are you able to see my cursor? So in this location,
Yes, ma'am.
if I'm going to use the same thing for scatter plot, let me show you the difference. Let me check whether it will work for. I'm not sure any example for scatter plot. Okay, same thing what I do. The same columns I'll show using a scatter plot.
Yes, ma'am. I understood the concept, ma'am. I got it clear, ma'am. What's the difference between?
Yeah, and better than strip plot is swarm plot. Okay, it is still able to segregate the points. Each individual point it is able to show. Okay, see here the same thing I have used, same columns I have used. In case of a strip plot, still there is overlapping. Okay, but in case of a swarm plot, you are able to understand each individual occurrence. Okay, all the data points are segregated horizontally. Okay, so that is the usage of means you are able to, from this you are able to understand how many data points are there at this location. So it means from this you are able to understand there are many gasoline vehicles with the horsepower around 65 or 70. That is the meaning of this. But if you see here, there is only one point. But in case of scatter plot, even the single point will appear as a single point, and even the set of points will also appear as a single point in case of a scatter plot. Okay.
So for clear visualization, we can go for this type of plotting
Yeah, if you
can be.
want to know the
Plot
number
will
of
be.
data points at a specific location, swarm plot will be much useful.
Okay, ma'am. Okay, ma'am. Ma'am, and what about the data types we can choose for this strip plot? It can be
Data
integer.
types in the sense, yes,
So,
strip plot takes this is the variable that I've chosen for x-axis is a categorical column, and this one is a numerical column. Okay, so a strip
okay.
plot is can be used for visualizing the relationship between a categorical column and a numerical column.
Okay, ma'am. Thank you so much, ma'am. And participants has asked to share your PPT and the codings to the
Yeah,
participants, ma'am.
I'll share those who are not in HTML file so that you will be able to visualize them. Means you will be able to see them in a browser. Okay. Those who have
Thank
already
you.
installed the Jupyter notebook, I'll share it as IPython notebook so that you can, if you want to make any changes and then rerun the code, you can do that.
Okay, ma'am. And there is one more question, ma'am. What library is good for data visualization, whether Alter or Matplot with Seaborn?
See, Seaborn is built upon Matplotlib. You cannot use Seaborn as such. If you want to use any of the functionalities in Seaborn, you have to download Matplotlib also because Seaborn is built on top of Matplotlib. Okay, what is the advantage of Seaborn is it has got more features or more interactive or more beautiful or aesthetic visualizations you can make in Seaborn than Matplotlib. Okay, that is the reason why we go for Seaborn. And there are in Plotly is also one of the more popular visualization tool available in Python, but it is a commercial version which there is a free version also available, which has got much more advanced features to create interactive plots. Okay, so I can show some example here in Plotly, where see here I'm not, if I keep the cursor here, I'm not able to see the exact value. Here I say roughly this is a gasoline vehicle with approximate value of horsepower around 65. I'm not able to check the exact value, right? But in case of graphs created using Plotly, if I keep a cursor on a particular data point, it will show me the actual value at that particular location. Okay, if that feature is also available in MATLAB, I guess. those worked on MATLAB must be able to understand what I'm saying. So if I keep a cursor on any specific location, it will tell me the position value, the X and Y values. Okay, that particular feature is not available in CBON. Okay, that is available in, supposing if you want to submit the reports, the visualizations that you have created to the top management, and if they want to see what is the exact value for a specific data point, then they can keep the cursor over the plot and then they'll be able to see. Okay, but for research purpose and for the student use, it is enough to use both matplotlib and pyplot. Matplotlib and CBON. That is enough. Yeah, I'll share both PPT as well as the Jupyter notebook for your reference.
Thank you, ma'am. Thank you for your very informative session, ma'am. I request Dr. S. Nikat Bushra, ma'am, to give the vote of thanks.
Yeah, thank you, ma'am. Thank you so much. Good afternoon, all. On behalf of St. Joseph Institute of Technology, I take this opportunity to propose vote of thanks on this webinar on data visualization in Python, organized by our Information Technology Department. At the outset, I thank our resource person, Dr. Haleema, Director, University of Stirling, RAK Campus, UAE. We are really enlightened with your knowledge, ma'am, and your presence. The way in which you explained data visualization in Python was extraordinary. You gave us your vital time in spite of your busy schedule. Thank you, ma'am. Thank you so much.
Thank you very much. Once again, I thank the management of St. Joseph Institute of Technology as well as the Department of Information Technology for giving me this opportunity. And I thank all the participants for their patience. Thank you very much.
Thank you, ma'am. I would like to extend a special thanks to our patrons, Dr. B. Babu Manoharan sir, our chairman, St. Joseph's Group of Institutions, our managing director, Mrs. B. Jessipriya ma'am, our director, Mr. B. Sasi Segar sir, and our beloved principal, Dr. P. Ravichandran sir, for all their inspiring words of wisdom that radiated a source of energy with us. I also thank to the organizing committee, teaching staff for their unflinching support and coordination. And also my heartfelt thanks to all the active participants. Thank you. Thank you so much.
Yeah, I'll share my
thank our department HOD, Dr. Kalarani ma'am, for her kind support for making this event a successful one.
You can make note of my contact details. I'm sorry. Okay, I'll share my PPT so that it is available, both my LinkedIn profile as well as email ID. I'll share along with the PPT. I'll share both the materials with the organizers and you can get it from them. Okay. Thank you very much.
Okay. Thank you. Thank you, ma'am. Thank you so much.
Thank you.
Dear participants, the feedback link is posted in the chat box. You can fill the feedback form, and the feedback form will be active only till today's night. So fill up the feedback. Once you have submitted your feedback, e-certificate will be sent back to your registered mail ID. Thank you all.
Thank you, Sibi. Thank you so much.
Thank you, ma'am.